Hello students, welcome. This is Mr. Walk. Today we are going to look at using a graph to write an equation. And we are still focusing on linear functions. This is our review of Algebra 1 material. And let's take a look here. There's two forms of a linear equation written here on your screen. These are the two that we have been working with, and let's go over them real quick here. So slope-intercept form here, point slope form here. Now, when you have a problem that says write an equation, unless it specifies which form to use, it's up to you to decide which form you're going to use. Sometimes you could use either one, or in other cases, there's only one that you could do depending on the information that you're given. So let's see here. For both of these, you're going to need the slope. Okay, and m is the letter we use for slope, and in both equations there's an m. So you have to have the slope either way. Where these two forms are different, for the slope-intercept, well, this b here stands for the y-intercept. So if you know the y-intercept, then you can write your equation in slope-intercept form. For point-slope form, this is what you need. Any point on the line. So if you know any point on the line, then you can use the point slope form, and you take the coordinates of that point on the line, x1, plug it in there, y1, plug it in there. So these spots in the equations that are highlighted, that's where you're going to plug in a number. And then the x and the y is just going to remain as a variable when you're writing the equation. Let's take a look here at the four different types of slope. Here's the first one. So as we look at the line and we're trying to figure out the slope, first thing we want to know is the line going up or down? And it could depend on how you look at this, but there's a standard way that we always look at a graph. The way we read a graph is the same way that you read a book or words on a page, which is starting from the left going to the right. So we're always going from the left to the right. And sometimes I like to think of maybe if we had a little guy here, little stick figure. Okay, if he's walking from the left to the right, he's definitely going up. Okay, he's walking uphill there. So this graph is what we call increasing, going up. And the slope here, now I'm going to write m. M is our letter for slope. The m is positive. Our slope is positive. Anytime the graph is going up or increasing, the slope will always be positive. Okay, now looking at this line, as we come from the left going to the right, okay, if you want, you can imagine a stick figure walking from the left to the right. He's definitely going down. Okay, he's going downhill. So this graph is decreasing. Anytime a line is decreasing, the slope is negative. Okay, so those are the first two types of slope. And these are the most common ones, okay? If the line's going up, the slope is positive. If it's going down, the slope is negative. Now there's two more types of slope. These are what I would call maybe more so like special cases. Let's take a look at this one here. So what's happening here? Is the line going up or is it going down? As we come from left to right. Well, here it's doing neither. It's staying flat. So here, this is what we call a horizontal line. It's not going up, not going down, going from left to right. Horizontal. Any horizontal line will have a slope of, hey, can you guess what number is neither positive nor negative? It's 0. 0 is the only number. We'll write equals. M equals 0. So a horizontal line will always have a slope of 0. And then our last case here, okay, what's happening here? Is this line going up or down? Well, it's hard to really say. It's going straight up, or you could say straight down. You can't really say one or the other because this line is vertical. Okay, a vertical line is going straight up and down. Whenever you have a vertical line, the slope is undefined. We're not able to give it a numerical value. So those are the two special cases. For a horizontal line, slope is 0. For a vertical line, the slope is undefined. And those there are the 4 types of slope. Let's look at some examples here. So here's our first example. We're given a graph and it asks us to write an equation for the line shown. And it doesn't tell us what form to use. Notice here it says write an equation. It doesn't say write the equation because there's more than one equation that can produce the line shown on the graph. So what I'm going to do here on this first example is show you a couple different ways to do it. This is more than you're going to need to do for any given problem when you have one like this, but it'll be good to see it a couple different ways. The first thing that we're going to need for sure is the slope, because remember, either form that we use, we need the slope. So let's do this. Let's use the slope formula. This is what we were working with last week. Just write it down here. y2 minus y1 over x2 minus x1. And remember, to use the slope formula, we need 2 points. So let's take a look here. And look, here's a point. And you always want to look for points that are cross exactly on the grid line. So for example, like I wouldn't want to use this point because I want something that's going to land on one of these where the X and the Y grids cross. So some of these points have been identified for us and filled in. So here's a point right here. Okay, let's see. Let's figure out the coordinates of that point. The X coordinate, and just as a reminder on how to do this, here's the X axis. That's all of these numbers. Let's see, this point, if I drop it straight down, it matches up with a -4. So a -4 is the X coordinate of this point. -4, comma. The X always goes first. The next one's going to be our Y value. To get the Y coordinate of this point, we have to project this point onto the Y axis, which means we're going to go straight over here, right? This is the Y axis, the vertical line. Okay, and what's that Y value? It's a 5. So the Y coordinate is a 5. Okay, so this is like my X1 and Y1. And then we can pick a different point. I'll just go with this one down here. And let's see here, the X value. So go to the X axis is right there. It's the 4. That's the X coordinate of this point. 4, comma. Now the Y value, remember it's going to come from the Y axis, so I have to project this point straight over here. -1 is the Y value. Okay, so I've got X and Y there. This is my second point, so I'll call this X2, Y2. So now I have 2 points and the coordinates, and I could use those in the slope formula. Let's go ahead and do that, and let's see what we get. After that, I'll show you a different way to calculate the slope. Okay, so we have subtraction on the top and the bottom. Y2 is a -1 minus Y1, that's a 5. On the bottom of the fraction, x2 is a 4 minus x1 is a negative 4. Let's keep the colors consistent. There we go. Okay, so there we have it on the on our slope formula. Now let's simplify this and see what we get. So on the top here, negative 1 minus 5 is a negative 6. On the bottom, 4 minus negative 4. Remember, when you subtract a negative, that's the same as adding a positive. So that's like 4 plus 4. That's an 8. So here's our slope. But let's see if we can simplify that. Anytime you have a fraction that can be simplified, you need to simplify that. And 6 and 8 both have a common factor of 2. So I could divide by 2 on the top and bottom. Okay, so 6 divided by 2, negative 3. 8 divided by 2 is a 4. Okay, so here's our slope. This is the slope that we're going to work with. Okay, so that's using the slope formula. Let me show you another way to do this. When you're looking at the graph, you can just figure out what the rise and the run are, and you don't even have to use the formula. So let's do the same thing. Let me start. Let's do this. We'll use the same points. So if I start from this point, and then I go to this point, we want to figure out the rise and the run. The rise is how high up or how far down. So how far up or down does the graph go? So let's see, I would have to go down all the way to there. And let's count that. That's 1, 2, 3, 4, 5, 6. So that's 6 units going down. So it's going to be negative 6. That's our rise. Our rise is a negative 6. And the run is going from left to right. So from here to here, if we count those, 1, 2, 3, 4, 5, 6, 7, 8. So the run is an 8. So I can also write my slope like this. Slope equals rise over run. And our rise was negative 6 over our run is an 8. And take a look, we get the same thing. That's the same thing that we had right here, negative 6 over 8. So we simplify that, we get the same value, negative 3 over 4. Okay, hey, and if you want to do rise over run and not have to simplify it, then you just want to find the closest 2 points. So I won't do it here, but if you go from this point to this point, figure out your rise and your run, it should be negative 3 over 4. Okay, so 2 different ways to get your slope. You only have to do it one way. Once you have the slope, then you're going to figure out which form of the equation of a line you want to use. We'll just look at these quickly as a reminder. We have slope-intercept form or point-slope form. Now, you know what? This is just my personal preference, but if I know what the y-intercept is, this is the way I'm going to write the line. Okay, we'll do it both ways, but this is the preferred way. If you know the y-intercept, I would just use y equals mx plus b. Let's do that here. Looking at this graph, do we know what the y-intercept is? Well, let's see, what does that mean? You remember what the y-intercept means? Here's our y-axis. We want to know where the graph crosses the y-axis, and it's right here. That's the point. Okay, you can see the value there is a 2. That's going to be our b value. The coordinates of this point, x comma y, are 0 comma 2. When you have a y-intercept, the x value is always a 0, so we're always just looking for that y value to give us our b. So that number 2 is our b, so we could do this here. If I write that over here, b equals 2. So now we have a y-intercept, and we already calculated here That's our slope. So I can write the equation of the line y equals mx plus b, and you're going to plug the slope in for m, plug the y-intercept in for b. So that's a 2. This is negative 3 over 4. Everything else is going to stay the same. Y equals mx plus 2. There's our answer. And we're done. We've written the equation. We've written an equation of this line here shown in the graph, slope-intercept form. Okay? I would just leave my final answer like that. If you wanted to use the other form, I'll just show you on this example how to do it. So the other form is looking up here, point slope form. So here we need the slope, and then we need any point on the line. So let's come back here. So I'll write it down right here. Y minus y1 equals m, x minus x1, and we have to plug in for the slope. So that's going to be this same m value here. All right, it's the same slope that we already calculated, negative 3 over 4. And then we're going to use the x and y coordinates of any point on the line. So let's see. Let me fill in the rest of this. Y minus x minus. Okay, so now we have to plug in the y1 and the x1. And again, we can use any point. So you know what? Let me just use this point here. We have those coordinates. Now, even though I called them here x2 and y2, that doesn't matter. I could still use these coordinates. So let's do this here. We plug the x value in here for x1, so that's going to be a 4. Plug the y value in over here, and that's a negative 1. And there it is. This is the equation. This is an equation of this line in point slope form. So let me just do this. Before I make this my final answer, I'm just going to clean this part up right here. Look, subtract a negative 1. That's the same as plus 1. So y plus 1 equals negative 3 over 4, parentheses x minus 4. Here's an equation of the line point slope form. Okay, now again, you don't have to do both forms. If it says write an equation, you get to pick. If, on the other hand, it tells you which form to use, then that's the form that you got to use. You just do one or the other. And just so you know, with y equals mx plus b, there's only one way to write this equation of the line because there's only one y-intercept. The b value comes from right here. That's the only y-intercept. But when you use point slope form, you can pick any point. So I chose this point and plugged in the numbers. If you had done it with this point, you would get a different equation, but it would still produce the same line. And, you know, I guess what I'll show you here, just the last thing on this one, is just to show you that these two equations give us the exact same line. So we'll take a look at Desmos. Again, this is more work than you'll have to do on one example, but I wanted to show you both ways. Let's just verify that both of these equations do give us the exact same line. So we're going to take a look at Desmos, and this is a way to check your answer. And I encourage you guys to do the same, to check your answer anytime that you're working on an assignment. You want to check and see if you got it right. This is how you can do it. So I have here open in my browser desmos.com. If you just type that in, click on graphing calculator, that's going to take you to this screen. And then I can type in, let's type in the first one we got, which was right here, slope-intercept form. So we'll type that in. Y equals negative 3 over 4 x plus 2. Okay, so notice here, this gives us a line on the graph, and we can compare. Let's see. Let me zoom out over here. Let's take a look at this graph. Did it give us the same line? Well, the original graph has a y-intercept at 0, 2, and looking here, look at that. That's where it crosses the y-axis, 0, 2. Now also, let's see, what were the other points? Let's see. Okay, let's look. All right, there's a good zoom. All right, let's see. This point was, okay, take a look at that. That point is negative 4, comma 5, which is also the same point that we have here, negative 4, comma 5. So this is looking good. This looks like the exact same graph. Let's see, we have the point 4, negative 1. Let's see, do we have that over here? Yeah, here it is. Look, 4, negative 1. That's it right there, 4, comma, negative 1. Okay, so we have the correct graph. So we know that our slope-intercept form is correct. Now let's just do this. Let's confirm the second answer. And again, when you do this on your own, you're not going to have to write it both ways, but I just want to show you that both ways are equivalent. They're both going to give us the same graph. So on a new line in Desmos, let me type in the point slope form, which is y plus 1 equals negative 3 over 4 parentheses x minus 4. Okay, and take a look at that. So the point slope form is the blue graph. And right now that's all we're seeing. And look, it's going through those same points we can see there. If I turn off the blue graph, there's the red graph, which is our slope-intercept form. So these two equations, which are different equations, give us the exact same line. So either answer is correct. And using Desmos to check your answers is a great thing to do. I encourage you guys to do it. Let's take a look at the next example. Write an equation for the line shown on the graph. And here I'm only going to do it one way. So let's do this. Find the slope. I'm just going to use the rise over run because I find that pretty easy to do when I'm looking at a graph. So if I start from this point and I go to this point, my rise is how far I'm going up. It looks like there we're going up 3. So 3, that's the rise. And it's a positive number since we're going up. Run is how far do you go from the left to the right? 1, 2, 3, 4, 5, 6. Okay, so 6 is the run. So now I can write my slope m equals rise over run. My rise is a 3, run is a 6. Okay, that's my slope. Let's see, can we simplify that fraction? We can. The top and the bottom can both be divided by 3. So this is going to simplify to 1 over 2. The slope here is 1/2. All right, and what I'm going to go for now is slope-intercept form, y equals mx plus b. Since I can see on the graph, here's the y-axis, I can see where the line crosses is right there at that point. What's that y value? It's a negative 3. That's my b value. B is a negative 3. Okay, again, the coordinates of that point, 0, comma, negative 3. But the x value is always a 0. It's the y value that we're looking for of the y-intercept, and that is negative 3. So b equals negative 3. And so now y equals mx plus b. Going to plug in the m right here, 1/2. Plug in the b right here, negative 3. Bring down the rest of this equation. Y equals 1/2 x plus negative 3. And there's our answer. Before I make this my final answer, I see something I can clean up, and that's right here. Plus a negative is just the same thing as subtracting 3. So I'm going to write this as y equals 1/2 x minus 3. And I'm done. That's my final answer. I'm only going to do it with the slope-intercept form. We don't have to do it more than one way. I did that on the first example just to show you, but this is all we have to do here. So we're done. If you wanted to, you could open up Desmos and check your answer, right? You would just plug this in on Desmos and see, does it give you the same graph? You could compare. If you get the same graph, then you know that you got it right. I'm not going to show you that here, but that's something you can do on your own. Okay, let's take a look at the next example. Example 3. Write an equation, and here we can see that this line is one of our special cases, right? This is a vertical line. It's going straight up and down. Okay, vertical line. And since this is one of the special cases for the slope, if you remember, the slope is actually undefined. So undefined means I can't give it a number. I can't assign it, and I can't look at this graph and say, oh, the slope is a 10. The slope is a negative 1/2. There is no number that describes this slope. So that means when we write the equation, it's going to look a little bit different. And for our special cases, our vertical and horizontal lines, the equations of these lines actually are simpler. It's going to be as simple as this. A vertical line, now we can see here, it never goes through the y-axis because it basically runs parallel to the y-axis, but it definitely does go through the x-axis. And we can see right there the x-intercept is at a -2. This point has coordinates -2, 0. And if we look at any other point on the line, let's say right here, the x value is a -2 and the y value is a 1. And then if we look, let's say we look up here, the x value is a -2 and the y value is a 3. Okay, guess what? Any point, we'll do one more down here. X value is a -2, y value is a -3. If you look at the coordinates of these points, there's a pattern. And that is the x coordinate in all of these is a -2. The x value never changes. So the way that we write the equation of this line is as simple as this. X equals -2. That's it. That's the equation of the line. If you go to Desmos and you type this in, you're going to see a vertical line going straight up and down through the x-axis at -2. That's all it is. So it's kind of an easy one when you have a vertical line like that. Now the next example, our last example, is a horizontal line, and it's a similar case here. This is a horizontal line going left to right. It never crosses through the x-axis, never touches, because it runs parallel to the x-axis. But of course, look, here's our y-axis, and it does cross the y-axis. You see that right there? It happens at 4. Okay, the coordinates there are going to be 0, 4. That's for that point. Now let's see, what about this point? The coordinates here are going to be 3, 4. The coordinates over here are going to be -4, 4. And there's a pattern here. With these coordinates, the y value is the same on all of them. Horizontal line, all the points will always have the same y value. In this case, it's a 4. And the equation of the line is going to be y equals, right? These are all y coordinates. Y equals 4. And that's all it is. So it's a very simple equation for the horizontal line and for the vertical line. If it's a horizontal line like this one here, it's y equals a number, whatever number you see it going through. And then when it's the vertical line, it's x equals the number. So that covers the 4 examples that I have for you. The last thing that I have for you here is some problems for you to try. So take a look at these here. Why don't you pause the video and take a look at each one of these. See if you are able to write an equation for the line that's shown on the graph. And then when you're ready to check your work versus mine, you can unpause the video. Now remember, there's more than one way to write an equation of a line, but just so you guys know, what I'll be doing is I'll be writing it in slope-intercept form, y equals mx plus b. For the special cases, we'll see those equations are simpler, but I'm going to write my answers in y equals mx plus b. If you choose to use point slope form, you would just have to confirm using Desmos is your equation equivalent to mine. So go ahead, pause the video, give these a try. When you're ready to check your answers, you can unpause and take a look.